Okay, it is 5:30, so we will go ahead and get started. Aloha again, everyone. Welcome to a special presentation tonight about what impact did Maui's polystyrene ban have on our beaches, presented by Dr. Jennifer M. Lynch, co-director of the Hawaii Pacific University Center for Marine Debris Research. We're all very excited that you're here. I'm Jill Wirt, your MC. I am a project and research coordinator at Maui Nui Marine Resource Council. Tonight's presentation is part of Maui Nui Marine Resource Council's monthly Know Your Ocean speaker series, usually held on the first Wednesday of each month at 5:30 p.m. via Zoom. This monthly series is supported by the County of Maui Office of Climate Change, Resiliency, and Sustainability. A few things before we get going. You'll notice that your microphone is on mute. Please keep it on mute during the presentation to avoid any distractions. And we invite you to submit any questions that might come up by using the questions button on the lower edge of your screen. We will leave some time at the end of the presentation to answer some of those questions that come up. And now it's my pleasure to introduce you to our presenter. Dr. Jennifer Lynch has worked for the National Institute of Standards and Technology since 2003 and became the co-director for the Hawaii Pacific University Center for Marine Debris Research, or CMDR, in 2019. The CMDR was purposefully established in Hawaii, one of the most plastic polluted marine environments. Dr. Lynch's research focuses on developing optimal methods to quantify and chemically characterize plastic marine debris to answer questions about pollution quantities, sources, fate, transport, effects, and reuse. She's authored 61 peer-reviewed publications and 4 book chapters and mentored over 45 graduate students. Dr. Lynch is one of 8 co-authors on a study titled "Did Maui's Expanded Polystyrene Ban, County Ordinance Number 4457, Improve the Amounts or Types of Plastic Pollution on Maui Beaches?" The study abstract states that in order to protect native wildlife and Hawaii's unique coastal environments, reduce plastic waste, and promote the health and welfare of the residents of Hawaii, bans on single-use plastic items have been implemented by some local municipalities. However, the impacts and effectiveness of these policies has been rarely studied. We're thrilled to learn about the results of this study, so please join me in welcoming Dr. Jennifer Lynch to our Zoom stage.
Thank you so much, Jill, and thank you everyone for coming this evening. It's really a thrill to be invited to this because we did this project several years ago and we've wanted to share it with the Maui community, but we weren't exactly sure where was the best place or event to do it. And so when I was invited to this, I said, there it is. So I'm really excited. So yeah, we'll be talking about the Maui Expanded Polystyrene Ban. And looking to see if it changed anything in the on the beaches. So I have several co-authors on this study that has not yet published. So this is data that's kind of been sitting in the coffers for a while, and I'm really glad to have dug it back out. We've got to get this published, but many students and faculty from HPU, Center for Marine Debris Research, were involved in this study. There's my name. And then Cheryl King from Sharkastics was heavily involved in the sampling on the beaches. And so was Jens Curry and his interns at the Pacific Whale Foundation. So kudos to all of them. I am a federal employee with the National Institute of Standards and Technology, and that requires me to say that if I mention any brand name of any kind, it does not imply that I am recommending it, nor does it mean that it's the best available for the purpose. A brief introduction into the Hawaii Pacific University Center for Marine Debris Research. We are a very passionate group of young scientists with a strong mission to develop and apply the best possible methods to investigate a bunch of things about marine debris. And thanks, Jill, for listing them all out for me. I'll reiterate them. We try to measure the amount of plastic in the ocean, where it's coming from, how it moves around the ocean, how it degrades, and its ecological and economic impacts, as well as ways to reuse the plastic out of the ocean. We, of course, need to disseminate this knowledge to inform management and stimulate stewardship. And I'm excited that we're able to do this tonight through this event. And absolutely everything we do is striving towards a trash-free ocean. That is our passion. Everything involving plastic pollution research is multidisciplinary. We're quite strong suited in biology and chemistry. And we have collaborators in the rest of the pillars of academics, including physics, engineering, economics, and political science. And we hope to build up those other pillars within the center so that we have active collaborations crossing over these disciplines in short time. We do not focus on a particular size class of plastic particles. We study from nanoplastics, which are smaller than 1 micrometer and can cross cell membranes, through the microplastics that are shown here in the picture, up to mesoplastics that can have brand names and easily sourced, back to its manufacturer, and then up into the macro and the megaplastics, very large plastic pieces that might be considered derelict fishing gear, as an example. And so we study the entire continuum, and very different methods are needed for each size class. As a brief introduction to plastic pollution issue in the environment, we as a society began using at a commercial pace plastics only in the 1950s. So this is only about 70 years old of an issue, but it's an exponentially increasing issue because our production of plastic is still on an exponential rise. That also means that the plastic waste is also on that rise. And very little of it gets recycled, turned into another plastic product. Great efforts are happening in the US government and around the world for circular economy. And I'm a part of the NIST Circular Economy Program, looking for ways to increase and improve the circularity of plastic products. But unfortunately, what we have today is the estimate that 8 million metric tons of plastic debris is being dumped into the ocean per year. In 2015, that was approximately 1 garbage truck dumped per minute. In short order, we'll be increasing that to about 2 trucks per minute. And by 2050, it's predicted to be 4 trucks per minute. So this problem doesn't appear to be going away anytime soon unless society makes some very giant changes. And this paper by Borrell talks about what it's going to take to make those changes to keep us at or below the 8 million metric tons going into the environment, into the oceans. And really the efforts are going to happen in the upper middle income countries and the lower middle income countries. Those are the countries that are growing through time and growing their economies. So there's more plastic usage in those economies and they have less capability of dealing with their waste. So waste process, waste streams need to be increased in those countries substantially. That's not to say that the US doesn't contribute to this. We absolutely do. A recent report came out about that topic. And I'd encourage everyone to go look at it. The Noaa Marine Debris Program was a big part of that report. But basically, We want to stay at or below 8 million metric tons. And to get there, we cannot be business as usual because we'll be up here around 60 metric tons by 2030, according to Burrell. This is the modeling of the plastic pollution quantities that are floating on the sea surface. So this doesn't include the plastics that are sunk to the bottom. This is a heat map, and it's broken out into the different size classes of plastic. So things larger than 200 millimeters or 20 centimeters are shown in this, and the microplastics are shown in these top two. And it's a heat map, so the warmer colors means the more plastic is floating on the surface in that area, and the cooler has lesser amounts. And you can really see that the Northeast Pacific, where the Great Pacific Garbage Patch is located right here, northeast of us in Hawaii, is the most plastic polluted ocean basin on the planet, which our proximity to that is pretty concerning because it results in things like this. This is a picture taken at Camilo on the Big Island. And this is one of the most plastic polluted beaches within the main Hawaiian Islands. And we certainly don't need science to provide proof that plastic pollution is an issue here. I think these pictures tell 1,000 words. This is a picture taken of the beach sand at Kahuku on Oahu, another heavily polluted beach. And this is showing how the larger plastic debris items are fragmenting into the smaller pieces, including microplastics. This is scientific documentation, and that scientific documentation adds sort of clout to the photos and provides strong evidence that helps set priorities for the best policy actions. And so this study was published by Dr. Heimbach at CMDR. He's the other co-director of the center looking at entanglement of seabirds in marine debris around Hawaii. And these are wedge-tailed shearwaters, and this is a booby species that had line entangling it, and then it got that line wrapped around its breeding colony trees. So entanglement is a real issue for marine organisms, and it is a lethal issue. Next up, some evidence is this report recently came out. I was so happy to see this from the Maui Ocean Center Marine Institute. I pulled some pictures off of it to give it some airtime because this is really important. Tommy Cutt is a major player over there, and what they're showing is that sea turtles around Maui are dying most frequently from fisheries interactions. So 87% of the stranded turtles are dying from fisheries interactions. If you look a little deeper into those interactions though, what you see is the number one cause of the strandings is entanglement in line. Now, whether that line was being actively fished or was marine debris, no one will ever know. If you catch the turtle with a hook, that is entanglement line with hook and line ingestion. Whenever you see the hook, that tells me it probably was active fishing gear. But this entanglement in just simply the line, which is getting wrapped around the flippers of the turtles, it squeezes off the blood flow, causing the flipper to become necrotic, and that can lead to infections and sepsis and death for the turtles. It can also hold them underwater and they can't breathe and they'll drown. There's many different ways these entanglements can kill sea turtles, and it's a really common thing. Next up is plastic ingestion. In 2019, Gove and Whitney et al., I was a co-author on this study, published larval fish the size of my pinky fingernail were ingesting plastic particles off of the coast of the Big Island, the Kona coast. And you can see these tiny little larval fish as examples, and then the item that we found in their bellies, and polymer identified those back. Most of them were microfibers, most likely coming from clothing. Hatchling, post-hatchling sea turtles, just a few days or weeks after swimming away from the nesting beaches, are eating this. These are microplastics found throughout the stomach and small and large intestine of sea turtle hatchlings here in Hawaii. This is a study that I lead. Very concerning, because little baby turtles should be eating food that give them nutritional value, not plastic particles. Another example, I'm just showering you with the depressing pictures of plastic pollution in the islands. This was back in October. I was on Maui for a trip, so now I'm bringing it really home here on Maui. This is the landfill in the Central Valley, and the wind was kicking up and blowing all of this plastic off of the landfill, and it was getting caught in the grass and fences and trees. And I just had to stop and take some photos of it because it was jaw-dropping. And I know that this has hit the news many times, showing a point source for some plastic pollution there on Maui. Another source of plastic that we see in the islands frequently, and we're doing a big study on it, is derelict fishing gear conglomerates, is what we call it. We've sampled 18 metric tons of this already at the center. These wash in from very distant locations, and they snag on our coral reef. And once they snag it, they fragment it, smother it, abrade it, and kill it. It bulldozes it, actually, as the waves are pushing this stuff towards the shore. So we've been very active in removals over here on Oahu. We've had a bounty out for derelict fishing gear with the longline fishery, the fishing fleet. As they go out into the garbage patch, they've been bringing us back these large conglomerates, and we pay them $1 a pound, and that worked really well. We're on the hunt for more funding to keep that going right now. Here's some scientific data coming off of Maui Beaches by Lauren Blickley et al. In 2016. And this study went out to 3 different sites, and actually we've repeated these 3 sites. So this is a really important study to explain to you. The sites include Pu'u Noaa, Po'olena and Wai'ehu. Wai'ehu being the one on the north shore, where we call that Windward, and then the leeward shore are these other 2. They get kind of a break from the ocean winds and the debris that's washing in somewhat. In this study, they categorize the different debris types into ocean-based, land-based, and then general source, where it could have come from a ship or it could have come from land, who knows. And what you see is that on the leeward sides of the island, these 2 sites, you have more land-based type of debris on the beaches. And on the windward side, you see more ocean-based debris washing ashore because it's on the windward side. Our newest data definitely corroborates this, and we've seen it over and over again. Very recently, in the last 5 years, it's become very important when doing plastic pollution studies to identify the polymer that makes up the plastic item. So many of you might recognize the chasing arrow recycling symbol. That does not mean that it will be recycled or that it can be recycled in your municipality, but it tells people and recycling facilities, sorting facilities, what kind of chemical is that plastic made up of. So drinking water bottles, disposable ones, are usually made out of PET, which is a number 1. Milk jugs are made up of high density polyethylene. PVC pipes are common in household drains, and a lot of thin film bags are made of low density polyethylene. But the one we care about today is polystyrene, right? because this is the focus of the ban. And what I need to explain for introductory background information is that when you put these different plastic items into the ocean, they stratify very differently vertically through the ocean. Some are going to float and some are going to sink. Polystyrene is interesting. If it's not blown with air like expanded polystyrene, it most likely will sink through the water column. So if it's extruded solid polystyrene, like hard plastic, it's going to sink in seawater. But if it's blown with any air, it's going to float. But the other floaters are the polyethylenes and polypropylene, and the sinkers are PET and PVC. They're much more dense than seawater itself. Another study that we recently published was looking at 4 different compartments of the Hawaiian Islands: the sea surface, where the floating polymers probably should be; Windward Beaches, which receive a lot of this offshore debris from distant sources; Leeward Beaches, where you get more beach goers and resorts and things being dropped from the air, not yet going into the ocean, so they haven't had a chance to sink. And then the sea floor around the islands. And we looked at the polymer composition in those 4 different places. This map is very busy. It shows the 11 different beach sites that we went to. The beach sites in green are windward, and the 3 leeward beaches are shown in brown. And we did some sea floor and sea surface around the islands as well. And what we found, this is the abundance of marine debris across those beaches. So now we're just looking at beaches. The ones that were leeward are these 3 with the brown line underneath them. And you can see the abundance, or the amount of plastic on those beaches, is really, really, really small in comparison to the large magnitude of plastic found on the windward shores. This is kind of a busy slide. I apologize. I thought about splitting it and I was like, no, you can see all of it in a row. We'll take it one by one. We'll take each row. So across the top shows the different compartments that we studied: seafloor, leeward, windward, and sea surface. And you really start to see a shift in the pie charts of the seafloor looks very different from the sea surface, and it sort of looks more similar to leeward, and then windward looks more similar to sea surface. These pie charts at the top have to do with what kinds of plastic they were, whether they were foam, fragments, line, sheet, whole items, or pellets, like we call them nurdles, pre-production plastic pellets. And you can see on the sea surface, most of it is fragments. And on the sea floor, most of it is a whole item and line. A lot of this is monofilament fishing line. Next up, we show the weathering code. So severely weathered is on the sea surface, that's shown in the orange, and less weathered is on the sea floor, because as soon as something sinks away from the sun, plastics are not going to degrade as fast. Photooxidation is by far the most prominent degradation pathway to degrading plastics. So what's on the seafloor is going to remain in a fairly mild degradation state. And down here, the most busy are the polymer identification. And the polymers are shown below so that you don't have to squint for the tiny little letters or understand what all the acronyms are. We've color coded it for you. So the blue shades are the polymers that would float on sea surface. So you can see the sea surface has only blue shades of polymers. The windward has mostly blue shades of polymers. That's the polyethylenes and the polypropylenes, with a few little nylons and polystyrenes thrown in there. On the leeward side, it's sort of 50-50. It's half and half. And on the seafloor, it's by far mostly those earth tones of browns to black, which are the sinkers. So this just really proves that the density of the plastic, its chemical density, really does impact its transport and fate through the ocean. Plastics that sink in seawater are going to stay closer to their source of littering, and plastics that float on the sea surface can transit the entire ocean basin fairly quickly, within weeks to months. This is another study close to home here in Maui County, looking at sea surface marine debris from the Pacific Whale Foundation. When they were out doing whale transects sightings, they were also looking for marine debris. And all the hotter spots are shown in red where they found more debris being abundant. So there's really abundant locations throughout the entire water here between Lanai and Maui. Maybe some hot spots where it might accumulate and congregate in this little area here. Again, we did the polymer identification for this, and almost all of it is floating polymers, as we'd expect. So polyethylene and polypropylene is by far the most abundant polymers in the marine environment here in Hawaii. Okay, now we get to the Maui County Ordinance, what we want to talk about today. It prohibits the sale, use, and distribution of polystyrene foam food service containers. So that's expanded polystyrene. It's blown with air, so it would float. Things like the clamshell and the polystyrene disposable drinking cups. This was intended to protect the county's environment and the welfare of marine and avian life, and to promote public health, reduce litter, and limit harmful materials from entering the environment. And so it had its own intent, and we are not testing the effectiveness of this intent. I want to make that clear. We're not testing whether the policy actually performed according to what the policymakers wanted it to do. We're kind of doing an aside, and I'll tell you about that in a minute. So this bill was signed in June of 2017, and it went effective on December 31, so New Year's of 2018. Some expanded polystyrene foam is exempt from this, so these things can still be sold, including raw meat trays. So normally you buy raw chicken or beef in that little tray, and then it's wrapped in thin film. Those are still allowed, as are polystyrene packaging products within boxes or coolers, things like that. And extruded polystyrene, hard polystyrene, is also not part of this ban. So a lot of disposable utensils are made of hard polystyrene, and those were not part of this ban. So our objective was to investigate if the Maui expanded polystyrene ban actually changed the amounts and polymer types of debris, plastic debris, on 5 Maui beaches. And our hypothesis was that pre-ban, if you had studied it long enough, you probably would see an increase on Maui's beaches, or maybe it's been stable recently. But after the ban, we hypothesized that we'd start to see a decrease of this expanded polystyrene foam on the beaches. So we worked with Cheryl King and Jens Curry on Maui to go out monthly and sample these 5 beaches. So 3 of these beaches are the same from the Blickley paper, Wai'ehu, Pu'unoa, and Po'olenalena, but we also added Ka'ehu and Kealia. So we have 3 leeward beaches and we have 2 windward beaches. It's important to note that 3 of the beaches were sampled with a totally different method, the Noaa 100-meter transect method, and a different time frame than Kealia and Ka'ehu. Those were done with a simple line transect for a longer period of time. So there's some apples and oranges in here that are very important for the study and make this data actually very complicated to analyze. But we did analyze 8,540 debris pieces in the study. So this was not a simple study. It was a very large, took an army of students to get this done. Okay, so these are the two methods shown separately with, you can imagine this is the beach, this is the vegetation line up here, this is the water down here. And in the line transect method that was used on two beaches, the person would go to the high tide line or the drift line and begin the transect walking parallel to the ocean shore. And they'd walk along until they collected 50 pieces of plastic, put them in a bag that were larger than 1 centimeter. The person would stop, use a measuring tape, and measure that length of the transect. Then repeat it a few feet down the beach 2 more times. So there'd be 3 transects on each day, and this was done once a month. On the other 3 beaches, the Noaa Shoreline accumulation method was used, in which the person collecting would start here and they'd walk towards the ocean, move a couple of feet this way and start going this way and continue to do this pattern across a known 100 meters segment of the beach. We broke that 100 meter segment into 3 different transects of exactly 33 meters each, so that we would have 3 transects within every month. So at least we have that similarity between here and here. But you can see that this is covering a whole lot more ground, and we do not know the width of the beach here, which is unfortunate because it makes the units that we can calculate apples and oranges. So our apples on the line transect method are the debris count per linear meter of the drift line. And over here in the Noaa method, it's debris count per meter of the segment, that 100 meter segment. So they might look like similar units, but they cannot be compared because the denominator is quite different. The time differences were in there as well. Ka'ehu and Kealia were studied, well, all of them were studied for the 6 months before the ban. So that was great. Ka'ehu and Kealia were studied for an entire year after the ban. And we broke that into early post-ban and late post-ban segments of time. The other 3 beaches that had the Noaa method done, they stopped at sort of staggered time points within the first 6 months. And unfortunately, the bags of samples didn't get labeled with the month of when they were collected. So when we received them here on Oahu, we didn't know what bag of sample belonged to December versus what bag belonged to July within the Po'olena. So we had to pool all of those bags together, basically, the data from all of those, because we didn't know which month was which. So there were some discrepancies and nuances in this data that make it challenging to analyze. But we're doing our best, and the data is still worth analyzing for this important objective. So once we got the samples here at CMDR, this shows the lab method. We would place all of the plastic pieces on white paper, number them, take pictures of them. We'd categorize them by fragment, by type, sorry. So whether they were a fragment, sheet, a whole item, we would record whether they were EPS, takeout containers, or noodle cups. We'd note their color, their longest dimension, their mass, and their weathering code based on Brignac et al. Then we would analyze them with for polymer identification with a long-winded name of a chemical instrument that we just call ATR FTIR. And basically this instrument, you put the little piece of plastic on a diamond crystal, push it down onto it. It sends infrared wavelengths through and looks at what it reflects and what it transmits back. And this is a spectra of polystyrene. And each sample would have its own chemical fingerprint, but if it's polystyrene, it will always have these particular bands, so we can identify it back to its polymer. We ran some stats. I'm kind of running out of time, so I'm gonna skip this. We're not fully done with all these stats, but we are looking at the data in every possible way we can so we don't miss something that could be hidden in the data. These are our results of identifiable items. And I'll just give away the punchline. It's quite similar to the Blickley of the ocean-based debris being on the windward shores and the land-based debris on the leeward shore. I've broken the 5 different beaches out with their bars underneath. These are the, excuse me, Windward Beach, and the brown is the leeward beach. You see, food packaging was pretty common throughout all of the beaches. Where it starts to deviate is fishing gear made up a large percentage of the windward beaches. And the opposite would be on the leeward beaches. We see a high percentage of smoking related debris like cigarette butts and toys and sporting goods, those beach toys. So we definitely see a difference of more local things, more land-based things on the leeward beaches compared to the windward. The debris amounts, what I'm showing here are all 5 beaches pre-ban. So this is before the ban took place. And again, blue bars underneath the columns. I really have a tickle in my throat, sorry. The blue bars underneath are the windward beaches and the brown are the leeward. And again, time and time again, all you have to do is go walk on the beach to find this. The leeward beaches have significantly lower concentrations of plastic pollution than the windward beaches do. These little blue bars are actually the amounts that were seen in Brignac et al. On these exact same beaches. So now we've gone back a couple of years later and we see very similar concentrations on those 2 beaches to the Brignac study. And if we look at Blickley and compare those, it looks like the leeward beaches may have declined a little bit through time from 2016 to 2018. But the windward beach stayed high at this same level that Blickley et al. Saw. If we look at pre and post ban, so pre-ban on each of those 5 beaches is in the blue, post-ban is in yellow. You don't see dramatic changes in the marine debris post-ban. In fact, Kai'ehu looks like it rose a little bit post-ban, and there's no significant difference here, so no change over the first year post-ban. Kealia, we did see a decrease. So this is the one and only beach. Actually, I couldn't find the statistics on these in the rapid pace it took me to get ready for this. I apologize. So I'm not sure what is significant on the right or not. They don't look very significant to me. So Kealia is showing some improvement, but whether it was expanded polystyrene foam can't be seen in this because this is just lumping all of the plastics together. Now, if we look at that polymer composition, what we see, this is very busy. These are our 5 beaches across the top, pre-ban, post-ban, but the first 6 months, and then post-ban the next 6 months, up to the 1 year. Polystyrene for to help you out with your eyes is shown in the bright yellow. So it's like highlighted for you. Wai'ehu looks like the yellow may have declined just a little bit, but this is not significant. No significant change in polymer composition. No significant change at Ka'ehu. So at the Windward Beaches, we're seeing no significant improvement from the ban. And these are the beaches that have the most trash, and most of it is washing in from distant sources. The Leeward Beaches, we actually do see a significant change between pre-ban and the post-ban time periods, but it is not caused by polystyrene. It is caused by a weird blend of polyethylene and polypropylene, which looked like it was huge. It was like 50% pre-ban, and then it decreased. So it's not polystyrene that's really driving this change, but visually it does appear there's a trend of decreasing polystyrene. At Po'olenalena and Pu'u Noaa, we do see significant changes. It is not caused by polystyrene here, and polystyrene is close to significantly impacting this, but the magnitude of change looks very small to me. So basically, let me finish up the results, then I'll conclude. So expanded polystyrene food debris items. So we went into the data and we found only those things that would have been impacted by the ban. And we have only done this for the first 6 months post-ban. And so the percent of food service EPS containers making up the whole amount of debris is here. And you can see that the line shows a slight decline through the different months, but it is not significant at all. So this is actually a stable trend. Kealia on the leeward side, where we might expect to see local changes happen, again, no significant difference in this first 6 months through time. Now we need to analyze the next 6 months, and that will be quite telling for the impact of the ban. So in conclusion, we have some preliminary results on 8,500 debris pieces. The debris amounts are dramatically greater on Windward Beaches than Leeward Beaches. We see this time and time again. We're starting to see maybe some small improvements noted after the ban on a couple of beaches, but not on those other beaches that have the most debris. And since a large percentage of debris washing ashore in Hawaii is from distant sources, local legislation concerning a particular single-use item are expected to make very minimal changes to the marine debris issue in Hawaii. What is really needed is international conversations to reduce the bulk of the marine debris coming here to Hawaii. And if we were to focus on local issues, boy, the sea turtle entanglement issue in nylon monofilament fishing line is a great concern. So thank you so much for coming. There were funds provided for this through Pacific Whale Foundation and the Noaa Marine Sanctuaries Foundation. An army of students helped at HPU, and Katie Shaw from NIST as well, and 3 people from the Pacific Whale Foundation. And if you're interested, follow us. If you grab that QR code, it'll take you to our website, and at the bottom you can find our social media links, or just pick up your phone and search us on Facebook or Instagram. So thank you.
Wow. Thank you so much, Jen. That was a ton of information and super informative and enlightening. So I'm sure people have questions. If you do have questions, we have about 10 to 12 minutes to go through them. So feel free to put them in the Q&A box. And if you're joining us from Facebook Live, you can go ahead and submit your question as a comment, and then it will be relayed to us. I don't have any questions right now in the chat, but I did have some come up myself. Pertaining to the ban in general, since I have other questions about other things, but pertaining to the ban, do you think that having a local county law like this could inspire other larger municipalities to follow suit, even though it doesn't necessarily have a huge impact locally on the beaches. Do you think it's creating this sort of, leading by example sort of thing?
Yeah, thank you so much for asking that question. And I love questions. So I'm encouraging the audience to start typing, post them in the, yes, I do. I think that Hawaii is already seen as one of the leading environmentally friendly states in the United States, maybe right there next to or behind California. And yeah, I think anytime that and in a policy is signed that is putting the environment first, is definitely a good thing and is a good role model for putting our environment, which we depend on greatly for our air we breathe, the water we drink, the shelter that we put around ourselves, the clothes we wear, the food we eat. We need the environment. And I think that it is still true that the majority of the human race across the world is disconnected, at least in the upper income countries. They're disconnected from the environment, and yeah, reminding people of that is important.
Absolutely. Thanks so much for that answer. There are questions starting to come in, so I will go ahead and read those out. Mark Dicos says, great presentation. Thank you to our turtle patrol team, saving so many turtles from entanglement. Any thoughts on the large change in plastic composition between the pre and post time periods, despite it not being a reduction in polystyrene?
Oh, any thoughts? Hi, Mark. Glad you're here. My thoughts are that the statistics are probably going to show significant differences because we have so many different kinds of polymers in there that even some small changes could lead to those significant differences. And we could go dive deeper into the data and pull out which items were those polymers that were driving that. We haven't done that yet, but thank you for planting that seed in my head. Now I can go figure out what were the polyethylene, polypropylene blends that were causing that pre and post ban change. I can tell you what it is already. My hypothesis of what we will find is that it was more ropes. A lot of rope used in fishing, especially the floating ropes, is a blend of polyethylene and polypropylene. So for some reason, that next 6 months was just getting hammered with more ropes, is my guess.
Right. That was actually one of my other questions, is for people who don't know what polyethylene and polypropylene is, could you provide an example? And you just did, so thank you.
Yeah, that's a blend. Blends are weird. They're not necessarily common in our like everyday household items. We either use polyethylene or we use polypropylene, but the ropes that we're finding in the marine debris are frequently blends, and we're trying to figure out why.
Interesting.
Yeah,
super interesting. It's fun. It's a good mystery project.
Yeah, there's a lot of forensics investigation going on.
Love it. Ronald Strickland asks, what can local people do to push this type of agenda, such as reducing fishing line, forward?
Oh, I wish I had a good answer for you. I'm gonna try to remain in my neutral role of scientist here, providing data and awareness of the scientific issues. Yeah, the lost fishing line is so common. I mean, countless. I think I've been out fishing a few times here in Hawaii, and the majority of the time, the people I was on the boat with lost their gear and their lines more frequently than they caught a fish. That was for sure. And, we have this very rugose coral habitat here, and the hook and the sinkers get caught up in that, and then they just cut the line. And there are some new products and research going on for biodegradable fishing line. I don't know what fishermen would ever want to use it, because it's not going to last as long, but I would love to see that switch happen. There are some other ways in which fishing could happen so that it's more likely that you retrieve your gear rather than it getting snagged and lost. So that, I think, needs to, the awareness of those, because I'm not super clear on what those are. So I'm not an expert to speak about them, but I know that they exist, sort of pop-up gear. So when you do lose it, something pops up so that you can go and retrieve it. Other people are doing cleanups, right? So a lot of scuba diving groups are now going to the bottom and pulling up the mono line. So, right, removal, but be really careful when you're removing fishing line from the seafloor on scuba or snorkel. You don't want to get entangled in it and drown. That disclaimer.
Yeah, safety first, absolutely. Good reminder. We have time for a few more questions. Lots are coming into the Q&A. So are you collaborating with any other research facilities across the world?
Oh, yes. We have about 52 projects going on right now. So to answer that is, the answer is yes. To give you the names of them, we're collaborating with the Joint Research Council of the European Commission. So they're similar to NIST in the US. It's sort of the same kind of government scientific organization over there. We collaborate with Woods Hole right now on microplastics and sediment cores. We collaborate with University of Hawaii on structure for motion imagery on coral reef habitat to look at the damage caused by derelict fishing gear. We are collaborating with the University of Hawaii and the Republic of the Marshall Islands to look at microplastics in fish that were caught around the reefs that the locals use as sustenance. So looking at that, that's an example.
Awesome. You're staying busy.
Yes, too busy. Way too busy.
Yes. Sherry asks if you found any differences due to the closing of tourism in the amount of certain plastic.
Can you ask that again? Sorry, I got a little distracted.
That's okay. Did you find any differences in the amount of certain types of plastic due to the closing of tourism?
Oh, closing of tourism. That has crossed my mind 100 times. We should be out there doing shoreline assessments during this pandemic, but we haven't done that. So it's likely that our collaborators have been doing that, and the samples exist within Pacific Whale Foundation or Sharkastics, because I know they're continuing to do the sampling. We got a little overwhelmed with doing the lab work and sort of had to cut it off at the 1 year mark for this study. But there have been some published works across the world about masks, face masks being more prevalent in plastic pollution nowadays, which makes sense, the rampant use of them.
I think I actually just saw a post from Pacific Whale Foundation that they found like 18 masks or PPE on one of the beaches just in a short amount of time on one of their cleanups. So it's definitely there. Okay, I'm going to do one more. I've been copying and pasting the other remaining questions into a document so that we can answer those at another time, or if you have contact information, if people wanted to reach out to you. I know that you're very busy, so we can always direct those to you as well.
Sounds good.
Yeah, so one more question from Stephanie Stack. Great presentation. Yeah, she's here. Great presentation. Although this did not have an immediate impact on beach debris, do you think this diverted polystyrene from the landfill?
Absolutely, yes. That would, I mean, no one, I don't think anyone's actually studying that scientifically, but it certainly should be, because it was interesting today. I had to Google to find a polystyrene clamshell, right, to get a picture of it for this presentation. And if you Google clamshell takeout, they're not polystyrene anymore on Google. They've shifted to the paper ones, or the more reusable, maybe the harder plastic ones. And so it was amazing to me to see that shift within Google, which is more, international than, yeah, 5 years ago, you would only find the polystyrene ones. So
Right.
I do think that there has been a shift away that's happening.
Great. Well, any shift away from polystyrene, I think, is a win. So thank you again so much. We're going to go ahead and wrap up, but thank you, Dr. Lynch, again, for your incredible and informative and relevant presentation all about your study. We're excited to continue learning more as the study gets published. So we will keep our eyes out for that. And to all of our audience members, thank you so much for attending Maui Nui Marine Resource Council's Know Your Ocean speaker series, sponsored by the County of Maui Office of Climate Change, Resiliency, and Sustainability. Maui Nui Marine Resource Council is a nonprofit celebrating 14 years of working for clean ocean water, healthy coral reefs, and an abundance of native fish for the islands of Maui Nui. Our next Know Your Ocean Speaker Series event will take place on Wednesday, March 2nd at 5:30 p.m. via Zoom. Our speaker will be Travis Liggett, who will be presenting on his mobile app, Flush Aware, that will tell users the treatment level and destination of their flush and actions for life downstream. To hear about signing up for this talk and to learn about other future presentations, please sign up for a free subscription to our monthly e-newsletter, Reef and Brief, at mauireefs.org. And as you've probably heard, Maui County's ban on plastic disposable foodware begins on March 1st, 2022. But if you love the ocean, why wait? You can get a free Hui Zero stainless steel bento box to use for your leftovers and takeout foods from your favorite eateries when you visit mauireefs.org and make a donation of $50. Since the start of makahiki season in November, Hananaia Aromatherapy has been donating a percentage of their sales to nonprofits here around Maui. This week, starting today, February 2nd through February 8th, they're donating 10% of a portion of their sales to Maui Nui Marine Resource Council. Visit hananaia.com to find some aromatherapy goodies. When you donate to MNMRC, you will be supporting our work to improve ocean water quality in Maalaea Bay. Our projects include our oyster bioremediation project, which has caged oysters in the bay, filtering sediment and other pollutants out of the water. We're also stabilizing the slopes of Pohakea watershed to prevent sediment runoff by planting vetiver grass. Vetiver is a non-spreading, deep-rooted, drought and fire-resistant plant that keeps soil from washing into the ocean during rainstorms. So far, we've planted 1,500 vetiver plants. We're measuring the impacts of our work through ocean water quality monitoring and also monitoring runoff from the watershed at streams and erosional hotspots. Our staff and volunteers are looking forward to a very special anniversary next week, the 100th sampling session of our Hui o Kawaiola Ocean Water Quality Monitoring Program. This community-based water quality monitoring program launched and conducted by MNMRC, the Nature Conservancy, and West Maui Ridge to Reefs Initiative in partnership with the State of Hawaii Department of Health Clean Water Branch, tests ocean water quality every 3 weeks at 29 locations in South and West Maui. So that's 17 sampling sessions every year at all of our sites. We're now approaching our 100th sampling session and are excited about celebrating it with our community and the dozens of volunteers who have made this work possible. Our team has also started conducting coral reef transects in Ma'alaya and Kihei, and these surveys will inform decision-making and establish current reef conditions and potential locations and impact zones for management efforts, including coral outplanting and rest zones. Data collection will include benthic cover and fish biomass and be paired with GPS mapping and aerial imagery to produce final report document. Surveys will be performed bi-weekly via scuba and snorkel from shore or by vessel in coordination and with existing efforts by partnering organizations and agencies such as the Nature Conservancy, Division of Aquatic Resources, and the University of Hawaii. If you've missed some or all of tonight's presentation, you'll be able to view it on Facebook Live on our Maui Nui Marine Resource Council Facebook page. It will also be posted on our YouTube channel, Maui Reefs. And thanks to our good friend, Darla Palmer Ellingson, you'll be able to hear interviews with our presenters on her program, Island Environment 360 on Hawaii media stations on Sunday mornings at 9 a.m. Last but not least, we want to thank all of our sponsors and supporters who are making our work possible. And we also wish to thank individual donors like all of you. Mahalo nui loa for making a difference. Thank you all again for joining us and have a wonderful evening. See you next time.